Hello friends, so today we are going to solve three questions. So in the situation shown in the figure, part A, what is the minimum force F that will make any part or whole system move? And B, find the acceleration of two blocks and the value of friction at the two surfaces if F is 6 Newton. This is our first question. So we have two blocks, 2 kg, and force F is being applied on it, and this is our 4 kg. So if force F is being applied on it, we are going to get a frictional force that is between 2 and 4 kg. Let us call this Fr1, which will try to move 4 kg to the right, and equal and opposite will be acting on 2 kg. And between the 4 kg and the ground or surface, let us call that as Fr2. So these will be the frictional forces or various forces that will be acting on 2 kg as well as 4 kg. So let's find out first of all what will be the values of Fr1 and Fr2. Okay. We can say that for Fr1 is between 2 kg and 4 kg. Okay. You can say friction force between 2 kg and 4 kg, which we call as Fr1. So Fr1 will be equal to, let us say, to our mu1, and we have 2 kg into g, and mu is given as 0.2, 2 into, let us take this as 10. So we are going to get g as, sorry, not g, but Fr1 as 4 newtons. And this was our frictional first part. Second part, let us find out the frictional force between 4 kg and the ground or surface. Friction force between 4 kg and ground, that is Fr2. So Fr2 will be equal to mu2, and this will be 2 plus 4 multiplied by g, mu2. Okay, my mistake. Let us change this, call this as mu1 and this as mu2. Okay. So mu2 now will be equal to 0.1, and this will be 6 multiplied by 10. So we get Fr2 as 6 newtons. Okay. So in the first part, in the A part, it is asked that what is the minimum force F that will make any part or whole system will move. Okay. So let us find out whether these blocks 2 kg and 4 kg will move together or they will be moving separately. So in the A part, we are going to make the comparison between the limiting friction. This will be our Fr1 max, and this will be our Fr2 max. So we are going to make a comparison between the maximum value or the limiting value of Fr1 as well as Fr2. You can say comparing the limiting, or we can say maximum value of frictional forces, that is FR1 max and FR2 max. So we can say that our FR2 max is greater than FR1 max. Okay. So from here we can draw the conclusion that 2 kg will slip on 4 kg under the condition, and this implies that 2 kg will slip on 4 kg if the applied force is greater than our FR1. So which basically means F is greater than FR1, and we are going to find the minimum value. Therefore, the minimum value of applied force F minimum will be equal to value of FR1, that is 4 newtons. Okay. This completes the first part. In the second part, we are going to find out the acceleration of 2 blocks and the value of the friction at the 2 surfaces if the applied force is 6 Newton. Okay. Now in this case, the applied force is given as 6 Newton. So we are going to find out the acceleration of 2 blocks. So this is your B part. Let me draw this is of 2 kg. A force F is being applied, and this is 4 kg. This is FR1. So we get FR1, and this is our FR2. Okay. And mu1 is given as 0.2 and mu2 is given as 0.1. So from the diagram you can clearly see that for the 4 kg block, and here applied force is F is given as 6 Newton. So we can say for 4 kg block, it will accelerate if FR1 is greater than FR2. It will accelerate if FR1 is greater than FR2. Okay, and we are assuming that there is acceleration A towards the right side. We put it here toward right side. So under this condition, the block 4 will be accelerating. But we already know that value of FR1 is, but FR1 is equal to 4 Newton and FR2 is 6 Newtons. This you can say that FR1 is not greater than FR2, therefore block 4 kg will not accelerate. So you can say, let us call this A4. A4 is equal to 0. So basically means the acceleration of acceleration of 4 kg is equal to 0 meter per second square. And next we are going to find out for 2 kg. You can say that for 2 kg block, so this is our 2 kg block, force F, and we have a FR1. Here mu1 is 0.2, and let us say it is having acceleration A in this direction. Force is 6 Newton. So obviously the F has to be greater than FR1, which is true because FR1 is 4 and applied force is 6. So it is going to accelerate. Applied force F is greater than FR1, therefore 2 kg block will accelerate with A towards right, and we can write the equation as F minus FR1 is equal to 2A, or A will be equal to 6 minus FR1 is our 4, and divided by 2. So acceleration will be coming as 1 meter per second square. Let us call this as A2. It's more easier. So this is our acceleration of 2 kg block. So this completes our first question. And we are asked for the second question as in the situation shown in the figure, find the acceleration of the block 2 blocks shown in the figure. So this is the figure, and find the frictional forces between all the contact surfaces. So we have 2 blocks, 2 kg and 3 kg. On the upper, a 5 Newton force is being applied, on the lower 10 Newton, and mu1 and mu2 are the respective their coefficient of frictions. Okay. So let us draw it. This is 2 kg and this is 3 kg. We have a 5 Newton, and to this we have a 10 Newton. Here mu2 is given as 0.2 and mu1 is given as 0.1. Okay. So first of all, let's find out what will be the limiting value or the maximum value of friction that is between 2 and 3 and 3 and ground. Limiting value of the friction between first is 2 kg and 3 kg, and let us call that as FR1, FR2 rather, this time with respect to mu2. So this will be mu2 into 2 into G, okay, and this will be coming as 4 newtons. And next is 3 kg and ground. So this will be our FR1, this will be mu1 into, this will be 5 into G, and this will be coming as our 5 newtons. Okay. Next, we assume that both the blocks are moving together. Okay. You can say assuming both blocks 2 kg and 3 kg move together with acceleration A. So let's draw the diagram. This will be now 2 plus 3. We have two external forces, one is 5 and another one is 10, and we are going to have a friction the opposite direction, and that is our 3 kg in ground, that is FR1, and it is moving the acceleration A in this direction. So we get our let us call this as F5 and let us call this as F10. Here also F5 and F10. So we can write the equation as F5 plus F10 minus FR1 is equal to 5 into A. So we can say that our A is our 5 plus 10 minus FR1 is 5 divided by 5. This cancels out, so we get acceleration A as 2 meter per second square. Okay, so this is the maximum acceleration with which both the blocks can move. Okay. You can say this is the maximum acceleration with which the blocks can move. Blocks 2 kg and 3 kg can move. Okay. So now we are going to find out, based on this acceleration, whether the necessary frictional force is available between 2 kg and 3 kg block. Okay. So next we are going to find out how much frictional force is required between 2 kg and 3 kg for the acceleration A, for the common acceleration A. So we can write the equation as F minus, that is F5 minus the frictional force is F2 is equal to mass is given as 2 kg and acceleration is coming as 2. So we can write our F2 is equal to F5 is our 5 minus 4. So from here we can say F2 is 1 Newton. So we can say that the F2, so now comparing F2 with FR, let me call this FR2 with FR2 max, and we already know that FR2 max is 4 newtons. Okay. We already know that FR2 max is 4 newton, so it means FR2 is less than FR2 max. Okay. Next, now we can make a conclusion that first is both the blocks will move with the same acceleration. Okay. This basically means no slipping between 2 kg and 3 kg. Okay. If there is no slipping between 2 kg and 3 kg, both blocks 2 kg and 3 kg move with same acceleration, which is our A, that is 2 meter per second square. And in the second part, it was supposed to ask find the friction between all the contact surfaces. And in the second part, you can say the friction between 2 kg and 4 kg, friction between 2 kg and 3 kg will be equal to 1 Newton. And next is 3 kg and ground, friction between 3 kg and ground will be 5 Newton. This is the, now here let us discuss these 2 points. Okay. In the first case, the friction between 2 kg and 3 kg is 1 Newton. Okay. Now we know that the maximum value, let me write it here, the maximum value of friction between 2 kg and 3 kg is our 4 newtons. So basically it means this is your FR2 max, or sometimes it is also called as a FR2 limiting. Now this value of friction will be only possible when slipping is going to take place between 2 and 3 kg. Okay, say this value of friction between 2 kg and 3 kg is only possible when slipping takes place between the two, between the 2 kg and 3 kg. And for this 3 kg and ground, we already found out or concluded that the slipping is going to take place between, as they are moving with the common acceleration, the slipping is going to take place between 3 kg and the ground. So under that condition, this value of the friction will be equal to Fr max. So you can say this is equal to Fr2 and this is equal to Fr1 max. Okay. So this is discussed here in detail, this portion. Now we come to our third question. Which states that block A of mass 2 kg is placed over another block B of mass 4 kg, which is placed on a smooth horizontal floor. The coefficient of friction between A and B is 0.4. When a horizontal force of magnitude 10 newtons applied on A, the acceleration of the blocks A and B are. So this A and B, they are having mass 2 and 4, and the friction between coefficient of friction between A and B is given as 0.4. So we can draw the figure. This is our A and this is our B. A force F, which is 10 newton, is being applied on it, and here coefficient mu is given as 0.4. So this will try in moving this direction with Fr, and equal and opposite force will be acting on A, that is called Fr. So this is the basic all the forces, and we can find out our Fr will be equal to mu A is given as 2 kg into G, and mu is our 0.4, this is 2 and this is 10, so Fr will be coming as 8 newtons. Or we can also say this is our Fr max, or we can say this is our Fr limiting. So we assume that both the blocks are moving together rather. Okay. Let's suppose both blocks A and B move together with acceleration A. So we have A plus B, that is 2 plus 4, and force F is being applied, which is 10 Newton, and A is the acceleration. So we can say our F is equal to 6A. F is our 10. So 10 is equal to 6A, or A is equal to 10 by 6, which will be coming as A is equal to 5 by 3 meter per second square. Okay, so this is the value of the acceleration when both are moving together. Now we are going to find out what would the value of the friction between A and B, so that it can move with the acceleration 5 by 3. Or we can also say this is the maximum acceleration with which A and B can move. Now next, let's find out whether this acceleration will be supported by the how much frictional force is required between A and B, so that they can have acceleration A, which is 5 by 3. So let us draw it for block A. So this is our A, F, and let us call this as FR. Okay. And it is moving with the acceleration A in this direction. So equation comes as F minus FR is equal to A is our 2 kg, so this will be 2A. So FR will be equal to F minus 2A. Applied force is 10 Newton, so minus 2, and acceleration 5 by 3. So this will be coming as equal to this will be 30 minus 10 divided by 3, or FR will be equal to 20 by 3, and that will be approximately equal to, this will be 6.6 something newtons. 18, yeah, something like that. And we know but the maximum, we have FR max is equal to 8 Newton. Okay. So if you make a comparison, FR is less than FR max. So there will be no slipping between A and B. If there is no slipping between A and B, both will be moving with same acceleration. So A and B move with A is equal to 5/3 meter per second square. So this completes the 3 questions. Okay, thank you.